So, respiration part 2. We start with the description of the third stage of the complex process of respiration. It is the transport of gases with the blood. So, the gases that are transported are oxygen and carbon dioxide. For the oxygen, we have two types of transport. First type is in physically dissolved state. Dissolved oxygen. So the fishes use this oxygen dissolved in water, but the amount of such dissolved oxygen is not very important, not very high. So the second way of transport is in chemical combination with hemoglobin. So the formula looks like that: hemoglobin plus oxygen. We have oxyhemoglobin. So this is the predominant way of transport, and one molecule of hemoglobin may carry up to 4 molecules of oxygen. So what factors determine the direction of this reaction? To oxyhemoglobin or back to dissociation, to hemoglobin and oxygen separately. So it is illustrated by oxyhemoglobin dissociation curve. Oxyhemoglobin dissociation curve. So we will draw this curve and we'll analyze it. So on abscissa axis we have the tension of oxygen. So it looks like partial pressure of oxygen. We will measure it in millimeters mercury. So the highest tension of oxygen we have in the lungs. It is 100 millimeters mercury. So this part will illustrate the situation in lungs. In tissues it decreases, and on ordinate axis we have the percent of saturated hemoglobin, so percent of oxyhemoglobin. The maximal value is 100, but we should say just from the beginning that it is not possible, because some amount of hemoglobin always binds carbon dioxide. So the curve will look like that: S form, so not linear relationship, and here the right side it goes close to the 100%, but never touches that level. So why this curve is S form? Because there is some cooperative interaction in the molecule of hemoglobin, and each new molecule of oxygen among this possible 4 binds hemoglobin more easily. So hemoglobin binds first oxygen, then second, then third, and fourth. So the fourth binds easiest way. That's why it's not linear, it looks like that. So the right side of that curve reflects the situation in lungs. So in the lungs, partial pressure of oxygen is high. That's why oxyhemoglobin is produced, so hemoglobin binds oxygen in that situation. Left side of that curve reflects the situation in tissues. So what happens in tissues? In tissues, the partial pressure or the tension of oxygen is reduced. Why? Because tissues, they consume oxygen, So what happens in that case? The saturation decreases. Oxygen is released from oxyhemoglobin, and oxygen is utilized by the cells. So and hemoglobin is used again